started. Yep, I just started. Okay, so I'll just say play with Kubernetes. Start. Okay. Now, so I'll just check kubectl get nodes. Okay, one nodes are here. One node is here. Now what I will do is I'll just create this container pod, the pod here. Okay, and we'll see here. Okay, so I'll copy this code. Okay, how do you deploy um, a YAML file? Okay, you create a YAML file. I will create pod.yaml. Okay, I'll paste the code here, and will run this. Okay, so how do you run it is kubectl apply -f. So whatever YAML file you need to run, okay, whether it contains deployment or any kind of object, if you have a YAML file, this is the command you need to run. So kubectl apply -f and the YAML file path. Okay, so here the YAML file is here, pod is created. Okay, and you can verify by kubectl get pods here. Okay, so you see my pod is getting created. Okay, so the command that I just ran is kubectl apply. Okay, so kubectl, let me open uh here. Okay, the command that I am running here. Okay, the first command I ran is kubectl apply -f and the YAML file path. Okay, so this will apply the YAML file, whatever content of the YAML file, it will just go and apply it. Okay, so let me change the YAML file. Okay, let me see if the container is running. It is running. Okay, and let's change the YAML file and change name of the pod. Okay, so I go to pod.yaml. Okay, there are few things that you cannot change in a running in the running object. So you created an object out of this YAML file, and there are few things that you cannot change directly. And one of the thing is the container name. If you can change the container name, it will delete the pod and then recreate it. Okay, so here instead of port number, so we will just change the Nginx version here. Okay, instead of latest, we will use some different version of Nginx. Okay, I'll go to the Docker Hub. Okay, and I search for any new any other tag other than latest. Okay, and see if we can update it. So before that 1.2 we can use some older version that will not be latest. 1.26 we will try to use. Okay, 1.26 is here. I can use this label here. Okay, so what we will do is we'll go and update this image to 1.26. Okay, and before doing that, let's see what version of Nginx is running and how do you get information about the pod. Okay, so to get the node image version, you can check out the pod details. Okay, so how do you get pod details? You get pod details by kubectl. Okay, get okay get pod and the pod name. Okay, so it will give you the state of the pod. And in the get command, if you replace it by describe, it will give you much more details here. Okay, so it tells you what is the name of the object. Okay, so it can be used for anything. Okay, let me copy this here. Okay, so to get details about an object in Kubernetes, so you specify like type here or kind here. Okay, and name here. Okay, so when you run this command, it will give you detail about the object that is running in Kubernetes. Okay, so it gives you what is the namespace. We'll talk about namespace in a moment. The service account, which node it is running, what is the start time, what are the labels attached with my pod. Okay, right now you see there are no labels here. Okay, so we will add a label here. You will see the IP of the pod, right? This is the pod IP in the cluster. Okay, the cluster has its own range of IPs. So this is the IP of the cluster. You see the container ID here. Okay, this is the ID of the container that this machine is running, and you see a image and the image ID here. Okay, so image ID Nginx, and there is a SHA here. So this SHA correspond to some tag in the Nginx. Okay, so if I go to tags and if I just search for this, okay, and you will see this is okay. This is not showing up here. Okay, I can go to here and I'll just search for first few lines so that I can go for it. It's not showing. Maybe how do I list? Okay, so okay, it's not showing the version here. Let's try to change this version and see what version is updated here. Okay, uh, so you see image ID here, and we will see this image ID will change it to 1.26 because we have specified 1.26 directly. Okay, so how do we apply it? Okay, simple kubectl apply -f and pod.yam. When you do this, instead of before when we run it for the first time, it says pod created. Now it is saying pod configured. Okay, pod configured in the sense it updated the pod. Okay, now we will see kubectl get pods. You will see one is running here. Okay, and it was restarted one time. Why it was restarted? Because we changed the image name. Okay, so what happened here? We updated the image from latest to some other image, which is like kind of upgrading or downgrading your application. Okay, so this way you change version of your application in Kubernetes as also. This is one of the example. Okay, so let's describe the pod again. Okay, and this time you will see the image here 1.26. Okay, okay, so this image got updated by applying the YAML file. In the event section at the bottom, okay, you will see that the latest event is at the bottom. Okay, and the so you see the first event was successfully assigned pod to control plane. Then it tried to pull the image, successfully pulled the image, created containers. Okay, and this was the last thing we were running. After some time, okay, so we updated the image, and then it is started to pull the image again. Okay, because this image was not present, and then a series of event here, and it got started. If your container has issues, you will notice those issue in the event section. Okay, let's try to do how does it work. If I change the pod image to something that does not exist, okay, let's say 1.2x. Okay, certainly this image does not exist. So what happen if I apply it? Okay, so pod is configured. If I do kubectl get pods, you will see that it has restarted. And let's try to see uh, what is the error here. So you see an error here, image error pull image. Okay, so your status in Kubernetes will tell you what is the state of the object. Okay, so here the my pod is in error state, and the state is error image pull. Okay, you can get more information about the state by describing the object. Okay, so sometime just by getting the object, you will know what is the issue. If it doesn't tell you doesn't tell you enough information, you can describe the object. So I'll describe the pod here, and in the event, okay, you will see that it says fail to pull image 1.2x. It says not found. Okay, and then the error called image error pull image, and backing off, like it is not able to create this image. It will back off and restart the container. Okay, and during the restart it will again use the same image, and it will fail again and again. So that is why when you do a get pod, you will see it restarted here, and now there is a loop back going on. Okay, so there is no way to recover this error, because it doesn't Kubernetes doesn't know how to recover a image pull error, pull back off. Okay, so what we can fix, how we can fix this? We can just rename it to 1.26. and that, okay, maybe 1.27. Okay, so so this is fine. We'll change it. Okay, we'll apply the pod, and now we do a get pods here. So now it is running. So the third command we learned is kubectl. So we didn't notice here. Let's so here kubectl get is another command. Okay, that you can use to get objects in the of any type. Okay, so you can specify kind, or you can specify all. Okay, so all will show you all the objects in the current namespace. Okay, and now now let's see how what happened when I run this command. So kubectl get all will show you all these objects in your cluster. Okay, so there are two objects. One is service Kubernetes, and the information about the service, and there is a pod. So when you do a get, a Kubernetes get, right, you, for different object you will receive different columns. Okay, so for service there will be type, there will be customer IP, there will be external IP, there will be a port. Okay, all these things are related with service, so you will see those things. In the pod you will see state, name, ready, status, restarts, and age. So depending on the type of object you're creating, you will get a different output here using kubectl get. Okay, but the syntax is same, kubectl get and that object you are looking for. Okay, awesome. so so this is good. Okay, let me create one more pod. Okay, so I'll just copy this pod. Okay, and I'll just name it pod 2. Okay, and in pod 2 I say that the name of the pod is my pod 2. I'll just save it. I don't change anything, just the pod name changes. Okay, and what I will do is I'll do kubectl apply -f pod 2. Okay, perfect. It got created. Okay, you see created here. Cube get pods. You will see pods here. It's running now. Okay, so you created two pods, and they are running on the same. So if I want to get only pod 2, okay, you can do using okay, so you can get like pod and the name of the pod here. Okay, so for because using this you will only get the pod that you are requiring. Okay, um so same thing, okay, is there for labels. Okay, if I open labels, okay, if I apply labels to the pods, let's see how what happens. Okay, so in the metadata I will apply labels. Okay, and I will say this, the label is like app front end. Okay, so maybe you're working with an application which is 3 tier, like front end is there, back end is there, and database is there. Okay, so for each kind of application you will create separate pods. So like, okay, so you will have multiple front end application, multiple back end application, multiple databases. So how do you get all the front end in one go? We'll see in a moment. Okay, so so this is front end, and the other application. Okay, I will make it labels. Okay, and here I will say app is backend. Okay, and I will again create one more pod. Okay, and this pod 3. Okay, sorry, no, pod 3 will be database. Okay, so and I can also say team, and I can say DevOps SREs. Okay. So I added a DevOps SRE team. Okay. Now, if I want to get all the pods that are front end, what I can do? So I can get, there is a kubectl get command. Okay. And I can specify the pod here. I want to get pod. And how do I get pod? by passing the label app equal to front end. Okay, so when you do this, so app is equal to front end is there is no application. Okay, get pods. Okay, I didn't apply it, so that is why I'm not getting it. So kubectl apply -f pod dot YAML. Okay, pod 1 dot YAML, 2 dot YAML, and pod 3 dot YAML. Okay, now if I run this command, okay, L front end, you will see there is a front end application here. Okay, if I say backend, you will see there is no application called backend. Okay, and why is that? Did I misspelled? Labels. Okay, did I miss anything in this? Okay. Did I apply this? Hmm. Okay. So let's run this. Now you see backend application. Okay. And if I say grep, I need to check what are the labels I used. And you'll see database. Okay. So if I get all the databases, I just use -l and database. Okay. So this will give me, okay, I didn't apply this as well. Like -f and 3 here. Configured. Okay. The pod name did not change. That was the reason I was not able to. Okay. R3. Let me apply it again. And let me apply 2 here. Okay. So now if I get all the database, you will see database here. I can also see what pods are related to team DevOps SRE. Okay. So we will see one pod belonging to DevOps SRE. So this is how you can filter out pods based on the labels. Okay. So kubectl get -l app database will give you all the application which has all the pods which have database app is equal to database as label. Okay. So yep, this is what it's about pod. Let's see how you can manage pods in a better way. Okay, so you can create pod, you can destroy pods, but nothing more than that. Okay, so the useful thing happens when you introduce a wrapper around pod. Okay. So now let's see what are wrappers around pod. So there are wrappers called deployment. Okay, there are wrappers around pod in the Kubernetes world. So deployment is one of the wrapper. Okay, there is job wrapper. There is a cron job wrapper. Okay, stateful set wrapper, and there is another wrapper called. Okay, did I miss anything? Deployment, job, cron job, and daemon set. Okay. So what are these wrappers? Okay. So there's one more wrapper which is like not in use nowadays, which is what we call is replica set. Okay. So what are the properties of each of these wrappers? Okay. So the deployment is most used wrapper around a pod, and it provides you uh, ability to specify replica. Okay, replica of app or replica of pod. Okay, so it means how many pods you want for the app. Okay, so we'll see, and you can also specify uh how many application you want to manage from deployment. Okay, so maybe like you want to manage all the application that are belonging to team SRE. Okay, so this there it will apply the settings to all the pods that has a particular label. So you can use select. There's what we call is selector. Okay, so you select the pods using labels, and deployment will monitor those pod by itself. Okay, or if it doesn't exist, it will create its own. Okay, so this is deployment. It internally create replica set. Okay, uh, in the initial phase of Kubernetes deployment, replica set was created as a separate object. Okay, there was no deployment, but this replica set lack a lot of features. Okay, those features were introduced in deployment, and because deployment is doing exactly what replica set was providing and additional features, the replica set started diminishing. Okay, so nobody create replica set nowadays. They create deployment, and deployment internally create replica set only, and replica set create pods. Okay, so what is replica set? So replica set provides you this feature. Okay, so in the deployment, the feature replica is provided by replica set. Okay, so to provide a deployment provide replica of pod using replica set only. In replica set, you can define how many pods you want to get, like 1, 2, 3. Okay, and based on the number, you can create the number of pods are getting created. Okay, so let's see how deployments are done. How you create a deployment. So deployment are created using the kind called deployment. Okay, let's try to create this. Okay, and instead of doing like copy like this, I wanted to show you how you can create by your own. Okay, so you already know that how do you create a pod. Okay, you create pod like this. Okay, so to simplify this, okay, I'll name like Nginx. Okay, and namespace, I'll remove this. Namespace is not something we worry about. And labels, you can say owner app equal to uh, Nginx. Okay, now here I need to specify container. I will specify only one container, and the container name is Nginx latest. Okay, and I remove all of this. So this is a pod. Okay, so how do you convert this? How do you create how do you create a deployment out of it? So deployment can be created. We need to specify API version. Okay, so API version for deployment is app/v1. Okay, the kind for deployment is deployment itself, as the name suggests. Okay, metadata, you can put anything. The metadata, the only important thing is name. So I use Nginx deployment. Okay, so this is the name I'm using. Okay, so the fourth thing is spec. Okay, so the spec here specify how many replica you want to create per pod. So I can say replicas, say 2. Okay, so 2 Nginx will be created. Okay, and this whole all will be managed from single deployment. Okay, and later we'll see what is the advantage of having deployment replica set. Uh, so replica you can specify. You need to select uh, your pod, right? So selector you need to define, and you can define based on labels. Okay, and you can say labels app equal to Nginx. So these are the two important things that deployment contain. Because deployment need to run pod, you need to specify how to create a pod. So how which section defines this? The template section defines how to create a pod. And in template section, whatever you have in the pod, you put like this. So you copy from metadata and you put it here. Okay, so this is the spec of your. So this is what you need to specify in the. So this part, okay, so this part is nothing but a pod. Okay, and this part is specify what is the additional thing deployment providing on top of a pod. So it is managing this pod, and it is providing replica set, selectors, and there are other fields as well which are part of the deployment, but majorly you need to specify this thing. Okay, and same thing you will see here. Okay, so we will be creating a deployment. Okay, and we will specify 3 replicas, and the selector is based on the app here. Okay, so we'll match labels using app equal to my app, and the same app will be applied in the metadata section for the pod. So this is the pod metadata. Pod specification. We have removed. So if you see this, this part is exactly pasted here. Okay. So the only thing that are not here is API version and pod. This you don't need to specify because deployment know how to deploy a pod here. So we'll copy this one, okay, and we'll paste it in the pod YAML here. So I'll open another deployment dot YAML file, okay, and I paste it here, okay. When I apply this, kubectl apply command is same, okay, deployment. You will see a deployment got created, and to how to get deployment, you use kubectl get deployment. Okay, so you see there is a deployment called my deployment, and there are other properties called ready, up to date, available, and age. So ready says how many so you specified 3 replicas, and how many replicas are ready. So you see 3 replicas are ready. How many are up to date? So up to date is specify. So when you update your deployment, you update the image version, right? So the up to date will tell you how many pods are using updated image version. Okay, so right now it is all the 3 pods are using same image version. If any one of them were not using image updated version, it will show a lesser number here. Available, how many pods are available? So we created three pod, 3 are available here. Okay, so up to date and available will vary if you are doing a upgrade in the application. Okay, so where how so you saw this deployment. Okay, but how do you see pod? So kubectl get pod will give you the deployment. You see the deployments here, my deployment, the name of the deployment, and some random number here. Okay, so there are three values here. First value is the deployment name, the second one is the replica set name, and the third one is the pod ID. Okay, so so let's see where is the replica set. You can get replica set by kubectl get replica set. Okay, so now you see my deployment created a replica set for this, and this replica set created pods which are named like this. Okay, so so what deployment do is deployment creates a replica set. So you create a deployment, it create a replica set, and the replica set will create the number of pod you have designed. Okay, so this is how the deployments happens. Okay, so replica set, and these are pods. Okay, so this is how the pods information are propagated under the deployment. Okay, so let's describe this deployment a bit, and we'll see what information we can get from deployment object. So kubectl describe deployment. Okay, you need to pass the kind here and the name of the deployment. So in the deployment output, you will see what is the image you are using. Okay, what are the containers you are using. Okay, and this is the pod template. Okay, and it says the strategy type. So there are different upgrade strategy type you can use in deployment. The default is rolling update. So rolling update, when you update the Nginx image, it will update one at a time. Okay, and let's see how do we do it. Okay, and okay, we'll see in a moment. And you see the other information in the in the deployment. So where did we, okay, here. So it says the labels applied to deployment, and the label applied to the container. So label it applied label app equal to my app to contain to pods, but it doesn't have its own label at the top level. Okay, rolling upgrade strategy. how many percent of max enable, and these other properties you can always explore. They are important for when you do admin kind of activities on Kubernetes. Okay. At the end, you will see events, what happened to Kubernetes. So this is the only event that we have because we did not update anything on deployment. Let's try to do an update. Okay, I'll open deployment.yaml and I will use an image that does not exist. Okay, and you will see how does deployment take care of the failures here. Okay, so what I will do is I'll just apply this YAML file. Okay, configured, and now you see. Okay, you describe the deployment. It says scaling replica set, scaled up replica set. Okay, this was the first comment. After first second, it tried to scale up replica to 1. Okay, there's another replica set it created. So what it is doing is it is creating another kind of set of pods. Okay, and it is trying to create the first pod here. If this pod is successfully created, it will update the current replica set to all the update. Okay, so now let's say kubectl get deployments. Okay. So you see three up, so three ready, three out of three. It says one up to date. Okay, because we updated the Nginx image, right? That is why it is saying only one is updated. Other threes are not update, right? Available are they are available, but they are not up to date because we applied a updated version. It's not working. That is why it did not update the running containers. So this is how it gives you a high availability, okay, and fault tolerance. So it try to create another pod and try to see if that is running fine. If that is running fine, then only it will update the other pods. Okay. So now let's see how what is the state of pods. Kubectl get pods, and you see there's one deployment pod here, which is image pullback error. So if this is image pullback error, right? The other three will not be deleted until unless this is a success. So let's update our deployment so that it can go further. We were using 27 latest, and now we are using 1.26, and that should trigger a update here. I will apply the update. Okay, and now if you see get pods, it is creating. Okay, and once it creates, it will you see it created image, and then it terminated the old one. Okay, now you see the other two were already. So once one of the container got success, you see it was started, then 6 seconds, then 3 seconds, these three started, and the other three are terminated. Now you see the other three are terminated, right? Yeah, so this is how the deployment take care of the upgrade. So if any, if during the upgrade you have specified a wrong configuration, it will say that I cannot apply it and I will not touch the running application. Okay, so this is a running application. It tried to upgrade it, it failed, so it stopped any other upgrade. Okay, and when the upgrade is finished, it will try to stop, it will try to create all the container and then will delete the other three containers. Okay. let- okay, sorry, I was on call. Okay, so this is how deployment take care of your pods. Okay, by specifying. So there are many option in deployment. Okay, but the basics are like you can specify the replica set, and you can specify the strategy how you should upgrade your pods. So here it upgraded one pod, and if that is fine, it created all the three new pods and deleted the old one after creating the new one. Okay. So there are other one, like you create one and then delete one, you create another one then delete one, and create another one then delete one. So this is another deployment strategy which is called canary deployment. Okay, so you can decide what kind of upgrade strategy you need in the deployment also. Okay. All right, so this is deployment. Okay, so the other type of object is job. Okay, job is nothing but it's a batch application. So what is a batch application? A batch application is something that you run and it, it does some work, okay, and then stop. Just like you wanted to do a backup. Okay, so how do you don't do backup continuously, right? So your application run continuously, your backups are not running continuously. So it takes backup, and then it when the backup is done, it kills the process is killed itself. So the process that are short-lived are called batch process. Okay, so the job is a batch. Uh, the job is a object in Kubernetes which are used for job like batch kind of process. Okay, so let's see how you create a job. This is similar to how you create pod, but additional thing are added here, which is like there is a new API version, batch one. Okay, you define the metadata, you define uh, the template here, what template you want to use, and there are other different properties that you can specify with job. Okay, so I'll copy this one and see how the job look like. Okay. Sorry, not here. I'll go here and I'll create a job.yaml. Okay, and I'll paste it here. Okay, so what this will do is this job will create a pod. Okay, and the pod will print echo hello Kubernetes in the logs. Okay, and this way we will see how to work with logs as well. Okay, so I'll apply this kubectl kubectl apply -f job.yaml. Okay, kubectl get kubectl get jobs. You will see there is one job running here. Okay, and it says how many completed, what is the duration, what is the age here, nothing more than that. And when it finishes, you will see that the job is completed. Okay, so now you see the status of the job, it is complete. Okay, you can also, this job will stay here for a while. Okay, it's not like pod, when the pod is stopped, it will be removed. The job will stay there, you can restart the job. Okay, so how do you so let's see a kubectl get pods. So in the pod section, you will see there will be one pod which was run by this job. Okay, how do you so the next thing is, how do you see the logs that the job is the pod is printing? Okay, so this pod is running this command echo hello Kubernetes. We wanted to see output of the pod. So the logs, you can check logs of a pod by running kubectl logs and the pod name. Okay, so only object that have logs is your pod in Kubernetes. Okay, so you see here, when you do this, you can see the output of the process running in the pod. Okay, so this command, okay, the new command that we learned is kubectl log. So you can say pod name. Okay, so using logs command, you can check logs of a pod. Okay, so one more thing is, you might have multiple pods running in a container, like multiple container running in a pod, right? How do you filter out which container you want to check? Let's create the same thing in job, and using that we will try to understand. So we'll create two containers here. Okay, okay, we'll create two containers here. One container is C2. Okay, and other container is C1. Okay, so C1 C2 tells hello Kubernetes from C2. Okay, hello Kubernetes from C1. Okay, so I'll apply this change. Okay, and we'll see kubectl fly minus f job.yaml. Okay, what it is saying, field is at unmutable. Okay, now you see at the last it says field is unmutable because what I did is I tried to change the name of the container, which is not permittable for an existing object. Okay, so what I can do is I need to delete the job that I have created. So instead of apply, you can also run delete command. Okay, so that will delete all the all the object that you have created in the YAML. So delete command. Okay, so delete command is exactly opposite of apply command. Okay, so it will delete the object specified in the resource file. Okay, so this is fine, we deleted it, and if it doesn't find, it will not create it again. Let's do an apply. It applied kubectl get pods. So kubectl get pods will give you the job here, one job, and it is completed 7 seconds ago. Let's try to see logs of this job and see what will happen. So we are checking logs of a pod. Okay, and in pod there are two containers. Okay, so which container logs the Kubernetes will print. Okay, so let's see how it works. So kubectl logs and the pod name here. Okay, my bad. Okay, so now you see what is the first line printed here. It says defaulted container C1 out of C1 and C2. Okay, so what it tells you, right? When you do a kubectl log, kubectl will try to get the default container log, right? So it choose one of the container and it prints the output of that container. Okay, but if I want to get output of C2, how do you get the logs from C2? Okay, so you can get logs of C2 by specifying -c. -c is for container. Okay, so which container? I will get logs from C2 here. Okay, so now you see hello Kubernetes from C2. Okay, and this is how you get container logs. So like this pod is running multiple containers. Okay, one of the container is doing something and the other container is doing something else, and this is where you this is where you will need to know how to get logs from a particular container. Okay, can anyone tell me why will I run two containers in a same pod? Any example? Since any guesses why would I run two containers in a pod? Okay, so the question
Back,
is, yep,
backup,
sorry.
backup, right? Backup.
Backup is one is like continuous like uh so when do you run backup? You run backup daily or maybe every 6 hours, right? So you need to have yep, one, you are right. So okay, one of the cases you need to run backup every 6 hours. Okay, so the pod that you are, so the pod has two container. One container runs backup all this every 6 hours for another container, right? And the other container is running some application, it generates some data, and you want to back up that data into some external storage so the other container can take care of it. So it's an excellent example you have told, right? Backup is one of the way. What is the other case? Like any guesses? Why do we need? When do we use multi-container pod? Have you ever worked with database application? Like application that uses database? Any Laravel developer here or Node.js developer here or Django developer here? Any one of you? So when your application runs, right? Application runs, it connects with database. Okay. So your database also running in container, right? In some container, not along with the application. That container may the database will be empty, right? How do you initialize your application database? Okay. So the question is, how do you initialize app database, right? So you are using a database. Your application requires a particular table, okay, or database name. Let's say app database is the database name, okay, and inside database it need to create tables, right? Create so tables like users, okay, teams, okay, inventory, okay, ice creams. All these are tables you need to create in the database. Okay, so how do you create these in database? Okay, and that is where we need two containers. Okay, so when you run a pod, okay, the pod is an application. Okay, so there is an application here. Okay, in application needs a database. Okay, so database is running here. Okay, this is your database, right? This is a database. The app connects to database and it try to access this database. And if the database does not exist here, your application will crash, right? Your pod will crash. How do you prevent this, right? So we prevent this by adding, so this is a container here. Let's suppose there's a container here. We prevent this by introducing another container in the same pod, and this container is called init container. Okay, so this is a second container. This is a init container, and this run SQL script. Okay, so your application provide a SQL script that will create SQL that will create app all this database and tables in the in the database. Okay, so it will run SQL script for this database, and once this is done, your container will stop. Okay, or container will stop and it will not do anything. Okay, and the after this container is finished, your application container start, and it will run this. Okay, so this is why this is where you will need multiple containers in the same application. Okay, so when you run multiple container in the same application in the same pod, you can define the dependencies. Okay, so you need to start app only after your init container is finished. Okay, so that is why you might need two container pod. Okay, you can have multiple three container pod as well, four container pod as well. You can run this database in the same pod. Okay, so your application don't need to connect here. Instead, it can directly connect here. Okay, so there is no network latency. So the database is hosted in the same pod. Okay, all right. So this is why we saw how to get logs from multiple containers. Uh, so the two thing I want to discuss is cron job. Let's quickly see what is a cron job. Okay, cron job is nothing but same as job, but instead the the cron job runs in every scheduled manner. Okay, let's see cron job.yaml file. Okay, and I will paste it here. This is similar to container, similar to job, but it defines a schedule here. Okay, so the schedule defines when do you want to run container, or when do you want to run pod. Okay, so by specifying star star star, okay, you can go to a cron guru. Okay, and you can check out what is this. Okay, so it says I will run every minute. Okay, so this means this job will be run every minute. Okay. And the job will create a pod called my container, and it will run echo hello. So every minute it will run a pod and it will print a hello Kubernetes. Okay, so let's see how it works. So I will apply it okay, let's create an alias k equal to kubectl, so that I don't need to. Okay, so k apply minus f cron job cron job created. Okay, k get pods. Okay, nothing got created as of now. You see the age here 17, 18. So we'll see in a minute another pod will be created. Okay, and before creating pod, it will create the job here. Okay, so we'll see how does it create. Okay, let's wait for 1 minute. Okay, and it should create a cron, should create a job. Okay, get cron job, it got created. Suspend was active one, got job. You see it created a a job called my cron job and the random number to identify, and this cron job created pod here. Okay, and you can see the pod here, cron job, and after a minute another pod will spin. Okay, so your cron job are good if you want to do some scheduled activities. Okay, maybe you want to restart your database, maybe you want to kill your application after every minute or every 6 hours. Maybe your application starts slow after 6 hours. Okay, so you need to restart your application. So this is how you can restart your uh, application using cron job. Okay, so I use cron job in my role. I use cron job to take backup of Jenkins. Okay, so I run uh, Jenkins backup once a day. Okay, and it copies Jenkins home to S3 bucket. Okay, so that is where cron job is required. I also use cron job to notify me about the state of Jenkins job. So what I do is I use a cron job that will check how many jobs has failed in last one hour, and it sends me notification about the failed job. Okay, so email notification. So if I see that there are many jobs failed in last 1 hour, I will immediately be get alerted, and I can take action based on the number of failures. Okay, so cron job are required are are used in those space. Okay, any questions so far? Like we discussed deployments, jobs, cron job. Okay, and few commands that uh, is required for this. Any questions? Okay, no. So the next thing I want to show you is, and for that I will need multi-node cluster, multi-node cluster. Okay, and for that I will use Docker Playground because it provides me ability to create multiple nodes. Okay, so you can also use that. Okay, I will go here. So what I'll do, I will add an instance. Okay, and you see it gives me a cluster. So you can bootstrap a cluster using this command. I'll copy this command, copy this, and I'll paste it here. So we'll just copy this command and paste it. How do I paste it? I'm not able to paste. Okay, zip insert works. Perfect. So it's connecting. Okay. So it's not, don't worry about this. This is just instruction I'm following. I'm not doing anything. Okay. I'll just copy this one. Okay. And while it is running, I will add one more instance so that I can work with it. Okay. So now it is generating few things. Now it's just setting up a cluster, and I will set up a 3-node cluster. and you will see what like the for the next kind of object, I will need a multi-node cluster. Okay, perfect. So fine, we got a thing here. Okay, and I need to start using clutter. I need to follow this steps. Okay, just paste it here. It doesn't work. Okay, now I have started this. Now I need to run these three copy and so insert. Okay, so though not found, which is fine. And now I need to join the cluster. So what is the kubectl get nodes. Okay. Now you see one control node is here. I will add another node by running this. Okay. So this command you don't need to worry. This is just a way to center here connected. Now I'll just do kubectl get pods, get nodes. You see two here. It will come online after a moment. Yeah, it came online. Okay. I will add another instance so that I can add a third node. Okay. And I just need to run the same command that I run for this node. I'll copy this one. So this environment you can use when you want multi-node cluster. Okay. Now I have 3 nodes in the cluster. Okay. I can go and run kubectl get nodes. I see not ready. After some time it will come up. Okay, perfect. All 3 nodes are online. And now you see kubectl get pods. You see there are nothing running here. Okay. Okay. So let's run this cron job. Okay, just to see everything working fine. Cron job .yaml. Okay, vim not found. Vi cron job .yaml. Okay, I'll just paste it here. Okay, and I'll just save it here, and I will apply this cron job kubectl apply -f. Perfect. Kubectl get pods. Sorry, kubectl get pods. Okay, nothing. Okay, it's creating here. Okay, cron job. So it will run after some time. Okay, it is not active as of now. Um, okay, let it run after some time, and then we'll see what is happening. Okay, so while it is running, so what we wanted to check is the next kind of object. Okay, and because of this object, I had to switch to a multi-node cluster. Okay, so why? Because this object, when you apply this object, it will create one pod on all the nodes. Okay, so it will create at least one pod on all the nodes. And let's see as an example. Okay, I'll copy this. Okay, and I'll go to playground. Okay, and I'll create a daemon set. So this is called daemon set. Okay, and daemon set are object that will run one pod on all the nodes in the cluster. Okay, at least one pod on all the nodes in the. So let's see interaction. uh, I'll just add a alias so that I don't need to run this kubectl all the time. TL k equal to this. Okay, so k apply -f daemon set. Let's do it. Now k get pods. You will see there are 2 pods here. Daemon set, daemon set. Okay, and let's see here. Okay, it's running. So why it is creating 2 pod? Okay, if you see daemon set, okay, cat daemon set, you will see I didn't specify any replica. Okay, and you cannot specify replica for daemon set. Okay, so daemon set, if you see here, okay, if I draw a diagram here, So this is your Kubernetes cluster. This is your one node. Okay. This is your another node. Okay. And this is your third node. Okay. So when you run a daemon set is ds here. Okay. It will create one pod in each node. Okay. So it will when you add another node in the cluster, let's say you add another node in cluster, okay, so daemon set will automatically add one more node here, one more pod here. Okay, so where do you use daemon set? Okay, so you need daemon set when you want to monitor your cluster. Okay, one of the example here, you want to monitor disk here of all the nodes, right? You will be so when you monitor cluster, you will monitor all the nodes, right? So you will you want something running on the node that will send data to some external system that can give you detail about the metrics. Like this is a monitoring system, so the pod will send data to monitoring system, and there you can see what is the disk space, what is the memory metrics, what is the CPU usage. All these things you can get from the pod running here. So this pod that daemon set is spinning, it can be a monitoring agent. Okay, it can be like you want to synchronize clock of all the nodes, right? Okay, so this might be in Germany, this might be in India, this might be in Pakistan, this might be in USA, right? So these nodes need to have same time. Okay, so how do you make ensure they have same time? You run a pod that will update the timing on the node. Okay, so they can update time on the node by providing time capability. Okay, so daemon set are used when you want to run one pod in all the nodes. Okay, so why so you see here when we do a kubectl get pod, two daemon sets are running here. Okay, and when you see -o wide, okay, you will see that one container is running on node 2 and the another is running on node 3. Okay, you notice that nothing is running on node 1. Okay, and why is that? You can get that information from nodes. Okay, and because you have seen the role assigned to this node is control plane. Okay, and by default when you have multi-node cluster, the Kubernetes cluster will not allocate any pod to control plane. Okay, when you work in a cluster where there are multiple nodes, Kubernetes will not deploy a pod on a control plane. When there is only one node in the cluster and that is control plane, Kubernetes don't have a choice, so it has to create a pod in that machine. Okay, all right, perfect. um and I can show you one more thing. How does so you see here there are two daemon set running here. Okay, so if I get get pods, you will see two daemon set running here. And let's see if I add this cluster to Kubernetes, right? What will happen? Okay, I'll just paste it here. I add it here. Now it is trying to connect to this cluster. It is connected to this cluster. Get nodes. K get nodes. Okay, it is still not ready. Okay, K get nodes. Now still not ready, still not ready. Let it be ready. Okay, it's trying to be ready. This time it is taking a lot of time. Okay, you get nodes. Did it hang? Still not ready. Let's wait for some time. Okay, you get pods. Still okay. Not sure why this is not coming up. Okay, not sure why this is not coming. Maybe some limit on this uh, machine. Fine. Okay, let's ignore this one. I don't know why it is not coming up. Maybe they have limited it to 2 3 nodes. Okay. Yeah, so that is what Damon said. Okay, so rest of the thing let's continue tomorrow. Any question from today's session? I'll stop here. Okay, any question from today's session?